Alright, so in this video, let's consider motion under graphs. Now, motion under graphs can come in different ways and in different types. First, we are going to consider motion of a stationary object, okay? Now, this will be fixed at a certain distance. Now, for example, we have this time graph here, okay? Now, so we have a distance time graph and a displacement time graph. By now, you must be able to differentiate between distance and displacement. They can have the same units, but one is a scalar quantity while the other one is a vector quantity. Displacement has both magnitude and direction, while distance has only what? Magnitude. Now, how do we proceed from here? Now, when we say something is at rest or is stationary, it means it's not moving. Therefore, speed is not changing. This is what we call constant speed. When speed is not changing, it's called a constant speed. Okay. In other words, speed is 0 meters per second. That's what we mean by constant or stationary. Now, you might be familiar with the equation speed is equal to distance over time, in which, for example, I'm talking about this equation here, this graph here. Distance is not changing, it's the same. That will be 20 minus 20, which is the change. Remember, we take speed is equal to the change in distance over the change in time. Over change in time is between 0 and 5. That will be 5 minus 1. But 20 minus 20 is 0 over 4. This will still give us 0 meters per second. This applies here as well. Now, we will look at non-uniform motion or velocity or speed. Now, when you talk of something which is non-uniform is something which keeps on changing non-uniformly. Okay? Let's say at point A, your speed was 2 meters per second. Point B, it increases to 3 meters per second. Point C, it goes to 1 meters per second. So the speed is not changing uniformly. We call it non-uniform motion. Therefore, when you have distance and time, a non-uniform motion is drawn like that, the way it is. Even for displacement, it's the same like that. It can also be drawn like, so this is when speed is increasing, when velocity is increasing. Remember, when we talk of distance, you should always talk of speed. When talk of displacement, you should always talk of velocity. Okay, so here speed is increasing, while here velocity is increasing. What of when speed is decreasing? So when speed is decreasing, you draw it this way. And when velocity is decreasing, you draw it this way. This can only happen when you have distance and time, or displacement there and time. Okay. This is just the same as the previous one. Let's look at the speed time graphs. Okay. Or you get a velocity time graph. Now, when you talk of velocity time graph or speed time graph, we are talking of the interaction of speed with time. So speed will always change with time, and that will always give us what we call an acceleration. Okay. Now, that slope, the one which they are saying here, the slope of the graph is called acceleration, is what we draw it like that, or like that, or it can even be like that, or it can be like that, depending with the information provided. So a speed time graph has got speed in the y-axis and time in the x-axis. A velocity time graph, respectively, has got velocity on the y-axis and time in the x-axis. Now, let's say you have this. Okay? Then here you have your speed, and here you've got time. What type of motion it is? This is what we call uniform acceleration, because the speed is changing. Let me give you an example. Okay, let's consider these two graphs. So we have a speed time graph here and a velocity time graph. Now, for a body moving with constant speed, remember what we discussed. When something is moving at constant, it means one of the things is not changing. In short, when it's moving at constant speed, we mean speed is not changing, or in short, the speed is zero. The acceleration in this case will be what? Will be zero. Remember, acceleration is equal to change in velocity, which is final minus initial, over change in time, which is delta t. Now, when something is moving at constant speed, the acceleration is zero, like they have said here. It will give you zero slope or zero acceleration. It's the same thing that applies here. It also still give you zero. Now, there are things that we need to take into consideration whenever you are dealing with a speed time graph. You can still find distance here, but distance will be the area under that graph. I sent videos on how to go about area, acceleration, velocity on velocity time graphs. So you can refer to those videos, then you'll be able to recall how to find distance, time, and everything. But my main thing here which I wanted to show is constant velocity, non-uniform acceleration, and so on.